So as I said in the previous video, in this video we'll just be doing the graphical representation of the Doppler effect graph, right? So it's the graphical representation. So the graphical representation of the Doppler effect graph, it's going to be something like this. So on my x-axis, I'm going to have time in seconds. And then on my y-axis, I'm going to have frequency. I'm just going to write it like this because it's kind of hard for me to tilt in hertz, right? So I'm going to have frequency in hertz, right? Then I'm going to have something like this. So this part we call a dotted line. So my dotted line just indicates change, right? And this part we call B, right? So this graph, take note that this graph is for one listener, right? This graph is for one listener, and this graph has a scenario for approaches. I'm just going to explain it right now. I just want to write down everything. It's a scenario for approaches and a scenario for moving away, right? So the approaches is represented by part A, while the moving away is represented by part B, right? So let me just explain what's happening here, right? So if you remember in the previous videos, right, I said as the source of sound is approaching me, or if I am approaching the source of sound. So in the approaching scenario, right, we know that I as the listener have to register a higher frequency than the what? Than the source of sound, right? So if you look at A, right, A is registering a higher frequency than the source of sound because it is approaching the source of sound, or the source of sound is approaching A, right? And someone is wondering why A is just a straight line, right? It's because the velocity, or rather they say the speed of the source of sound, right, or the speed of the listener, depending on which object is moving, right, they have a constant speed, right? So the reason for us having a constant speed, so you need also to know then that speed, right, will always be constant, will always be constant, right? So the reason that speed always has to be constant is because I do not want my frequency to be fluctuating. So if speed was not constant, my frequency that the listener is gonna detect, it's gonna go up and down. Like the listener wouldn't detect a constant frequency, right? But then he would detect a frequency just fluctuating, going up and down. 1 minute he's detecting 480 hertz, the other minute he's detecting 490 hertz, the other he's detecting 500 hertz, because the speed will be changing. But then for our syllabus, the speed will always be constant, right? And then we also have part B, right? Part B is just the moving away scenario, right? So as you can see, I was here on part A, right? I was here. But then after a certain time interval, right? Let's just say, imagine this. I'm on the road, right? And a car is approaching me, right? So as the car approaches me, obviously it's what? It's scenario A. It's part A on the graph, right? Because I'm detecting a frequency higher than the source of sound, right? But then as the car passes past me, right? So it's now moving away from me, right? Which is this part. So this dotted line part is when the car is directly in front of me, right? But then the moment the car passes me, it's no longer directly in front of me. The moment the car passes me, right, it means that the frequency that I'm going to be observing is now going to be less than the frequency of the what? Of the source of sound. Therefore, that's why B is less than what? That's why part B is less than part A, because in part B, my vehicle is now moving away from me, whereas in part A, my vehicle is moving towards me, right? So I hope you guys understand what's going on, right? And most of the time with these graphs, we're gonna be doing simultaneous equations, right? Simultaneous equations. So most of the time, for you to solve, maybe let's say you want the frequency of the listener at part A and the frequency of the listener at part B, right? You're going to have to do some simultaneous equations, but then we'll also cover that as we'll be doing examples involving Doppler effect, right? So in the next video, I'll be doing redshift and blue shift, right? And I'll also be doing the application of Doppler effect in real life. And then I think that's gonna be it for Doppler effect. Thank you.